monitoring and troubleshooting using OnCommand Insight. So my name is James Holden, and I'm going to give you an overview of what monitoring and troubleshooting actually looks like. I'll give you the use cases and the challenge we see with this, and then I'll give the live demo of NetApp IT's environment and what that looks like. So the goal is to discover issues before they actually become real end-user affecting events. The challenge is you've got to get visibility across that entire infrastructure, regardless of where it is, on the on-premises environment or out in the cloud. And it's across the entire IT infrastructure set that we have the ability to discover and monitor. We pull in all the performance characteristics from the latency, the traffic, the errors in the environment, and then we've got customizable alerting policies that drill deep into what's going on.
Hey James, that chart, could you go back one step? That chart that you have there that shows the line chart, it says VM CPUs by operating system. So some of those are fairly flat, some are cycling. Is that?
Yes.
And what we're talking there is an operating system consumption of CPUs. I mean, so like Windows or something like that might be going up and down, whereas Linux is flat or something.
Yeah. So on this one, it's actually the data on tap 9.1 is the blue line at the top, because it tries to use as much CPU cycles as it can. We're running this on out in the cloud volumes on tap, as it's now called, or used to be cloud on tap, or then on tap cloud. It was consuming 100% all the time. That's what that's actually breaking down. The other ones are just spiking up and down. But we got the ability to slice and dice the data any way we want. We can then do groupings on that data subset. And when I jump into a demo in a second, I'll show you how I can create a visualization that looks just like that.
And the monitoring you're doing to get that information is on like a 5-minute interval, 15-minute interval?
It's configurable. Depends how fast the device is able to return the data. A lot of the devices, 5 minutes is kind of preference. 1-minute intervals is better, obviously. But then there's other devices out there that can't sustain that sort of load. 15 minutes is what they will give you. Things like a VMAX is only 15 minutes.
And you mentioned early on there was no agents? No
agents. We're doing this completely agentless. So we discover the environment in any method we can. So whether it be a CLI, an API, SSH, SMIS, we will pull the data whatever method we can do. We do it completely read-only. All we need is a IP address, and a read-only username and password, and usually then we'll just start pulling that data back. So we will grab the inventory data, we'll show the configuration, how the devices are set up, and what components are in the infrastructure within seconds. Pulling performance data, well, it's going to take a couple of polls before we can start drawing a line, but after 10 minutes, we've normally got some performance data coming in and lines starting to fall.
And you cover VMware, Hyper-V, OpenStack, Red Hat, all these guys?
All those guys, yes. All the major players in the market.
Good for you.
So in troubleshooting, the end goal is to really get back to your operational state as fast as possible. Identify what that bottleneck was and fix it quick as you can. The challenge with an IT infrastructure is often they're getting extremely complex. And there's a lot of different interconnected relationships between each of those underlying devices.
So James, my question on this chart is, what's the difference between a storage pool and storage nodes and volumes and internal volumes and those, you know?
Yep. So there's a different constructs within a storage array. Within the array, there's different compute heads in there. Those are the storage nodes.
Are you extracting compute information from a storage array?
We're getting the processor utilization from those storage nodes.
The controllers?
Yep, from the controllers. We've got the construct of the pools, we've got the underlying disks in there, and we've got the then internal volumes for a NetApp familiar
operating
audience.
System volumes and things of that nature? Or
sorry?
Operating system volumes for NetApp, or?
We're getting
information on that.
On the flex falls, we're getting the information on the LUNs on there.
You're monitoring also the fabric, because here is the storage fabric.
So I can monitor the fabric. So we can discover the Brocade or the Cisco fabric or even a QLogic. We can pull in all the kind of port details. We've got the full relationships of how the service path is flowing through that fiber channel network as well. But we're not purely fiber channel basis. We're obviously got the NFS and the SMB and the iSCSI connectivity as well. We can see all of that. And how the virtual machines are connected to that. But in the fiber channel world, we can really deep dive on things like the BB credit errors. And
is it all drilled down? So if I want to see what's going on over there, can I just...
You can drill down and down and down and down, yes. Yep. So
do you also support host endpoints that are connecting to storage solutions as well? So Windows operating system, Linux operating system, or is this storage focused only?
So I can see quite a bit of the host level information. I can collect file system utilization out of the box. I can also, I've got to collect, if I want to go agent based, so if I do want to get a little bit more detailed information, I do have the ability to use things like collectd and an output plugin for collecd to feed data back into OCI as well.
All right, and those
then I could do deeper level.
And those are third-party agents, or you have your own agent?
We've got an output plugin for collecd that people can leverage to, pull that information. So they can utilize what the open source community has created and then feed that data for the graphing and the visualization.
What about software-defined storage systems like vSAN, Nutanix?
Scale.io, yeah, we've got.
You connect to those as well?
Yeah, we can see into those. Right, so I'm going to now jump into a live demo, and this is really, really live because this is NetApp IT, and this is one of our what we call a staging server that's actually running and discovering a few of our data centers in the NetApp world. So this is the opening screen for OnCommand Insight. I log in with my single sign-on.
So the launch Java UI?
Yes. So we started with a Java UI back in 2002, whenever it was. Then Sunscreen was invented, and over the years we've evolved the Java UI. Since I've been with the organization, the Java UI, we've taken as many use cases as we can out of it and brought it into the web UI. But it still exists. There's still organizations that still leverage it.
When you add new features, are you adding them in both?
We're adding them in the web UI.
Is this Flash-based of HTML5?
HTML5. So here's my opening dashboard for OnCommand Insight. This is NetApp IT. So please don't be surprised that there is no other storage vendor in this environment. It's 32 petabytes of NetApp. It's a mixture of E-Series, SolidFire, and obviously ONTAP, a lot of ONTAP. And they've got multiple tiers of storage. There is a tiny bit of fiber channel in this, but you imagine it's mostly NFS and V-based. I've got some Brocade in there, and I've got a little bit of Cisco. I've got some high-level facts about the environment, how it's actually doing from a capacity and an efficiency perspective. Over here, I've got a little heat map of the arrays in the environment. As you can see, there's quite a few arrays. The bigger the text, the more I/O is being delivered on this particular array. And over here, I've got a same sort of a view for the virtual machine infrastructure as well.
So there's 6 alerts over. Is that 5 alerts for the admin? Is that this one?
There's 5 alerts for the admin in this environment. We'll drill into them later when we look at the admin section.
All right, go ahead. Sorry.
Well, it's better to look at the monitoring and troubleshooting side of this house. So I have a lot of different dashboards in this environment. It is used by NetApp IT to kind of investigate what's going on. I have a few that I really like to show. The intention behind our dashboarding is it's going to answer a question that people want to look at on a dashboard. So in the VMware side of the house, which VMs are in high demand? I have a dashboard that's now loaded that's going towards answering that question. So here's all the different hypervisors, all the different capacity of those hypervisors. Here's the memory utilization on all the virtual machines, what the average utilization is, the CPU, the I/O load. And if I wanted to trim this down. I know you wanted to look at one in the Hillsboro, Oregon.
For my own education, what's a memory utilization of a virtual machine?
That's the
Matt?
Well, it's how much
What
of
is-
the virtual memory you give it, it uses. Just like a Windows machine uses X% of
It'll
memory.
also be
The
over
reason I
commit.
was flabbergasted.
memory
is because
pressure.
It's an easy answer.
Sorry.
So what's the release rate on software, new features for OCI?
We're doing 3 new version releases a year at the moment.
All right.
And so I have multiple ways of answering that as well, because data sources and collection from different devices is outside of that release cycle. So we react on a customer need basis. So if I have a customer that's demanding support for, I don't know, pick a storage device, pick a hypervisor, and they say they want it, and we'll prioritize it, we push it into our engineering cycle, and then we can release that as a patch. And usually that's, we're patching then their environments whenever they want.
And your patching, is it, how do you consume it? Is it a virtual appliance? Is it, you got to stand up a server and
So
install the software?
how are you consuming OCI?
Yeah.
It's usually either a Windows or a Linux server that they put in their environment.
All right. And
Sometimes it's a virtual machine. We ship the binaries. They build the operating system and the box,
right.
and then we.
And what are the architectural models that you support? Is it just a standalone server? Can you do clustering, multi-site?
A mixture of different environments. As you imagine, our customers are extremely complex in the way they've got stuff set up. The largest of the large, what they will have is probably multiple OnCommand Insight servers, because there's a limit that we start to reach. You're talking hundreds of thousands of virtual machines and thousands of arrays. So they probably have biggest ones, maybe tens of operational OnCommand Insight servers. Those then federate up into a single data warehouse. So they've got the whole holistic view. Now, there's also the case that there's firewall environments. There's people that have really remote locations. Maybe they have a research facility in the Antarctic, I don't know. But they need to collect the data from that environment. And so what we have as well is the ability to have a remote acquisition unit, which is a really cut down collection server that they can feed the data from back into OCI.
And what's the rule of thumb that defines when you need multiple instances to scale your
It's
platform?
the number of objects that we start to monitor.
What's the rule of thumb for the number of objects? 10,000?
Plus 25,000, I think is probably.
Is it more of a feel, though, when you start to sense that your performance metrics
Yeah, and my
responding?
admin little gauge that you all noticed the little red badges before probably were highlighting that this environment may be coming up to some of its limits on terms of either CPU in the environment or the memory utilization. Yeah, all these graphs. Oh, I can zoom in on each one of them. Clicking on them will link and launch me to different viewpoints. There's groupings on there. Creation of a dashboard is very simple. A widget library. I can start bringing in my own little visualizations of the world. So here, we wanted to make it as kind of user intuitive as possible. So if I want to look at storage, what do I want to look at? I want to look at different objects. Here I'll pick the storage. Here's my performance counters I've got on my storage environment. Everything from I/O to throughput metrics. I then can start filtering that down. And I can filter it by those constructs that we have in the system. Either attributes of the devices that we've already gathered, things like what family does it belong to, what microcode version, and then there's other attributes that are either manually or automatically assigned, things like business entity, application, what else have we got? Maybe a performance characteristic. Maybe I want to look at all the storage arrays with storage nodes that got high utilization on them. So let's do it by family, and let's do it by, I'll see if I've got a solid fire. So as you can see, my graph now changed. I can then roll that data up by time periods. I can aggregate it over different time intervals. I can get more kind of granular on those data sets. And then if I wanted to compare that against, let's compare it against a virtual machine performance. I can then look at my virtual machine. I've got whatever metric you want really on the virtual machine level, CPU co-scheduling time, all the way through to swap rates, throughput, latency metrics. Let's compare it against the latency on my virtual machines. And this is now aggregated by everything. If I wanted to roll it up by operating system, I can do that, and it's going to create multiple graphs of those different components.
So when you did the pull down, one of the things was end of life. Are you guys able to do any kind of end of life monitoring?
So there's multiple ways they can do the end of life. Often it's been put into a CMDB, and then we can take the feed from that. Other than that, it's a manual entry that they can bring in that system. But yeah, you think of a construct that you want to group your systems by, we can annotate that data, and then they can pull it into the system. So I've now got a dashboard I can build. And
Is there a correlation between VMs and storage?
yes.
So I can, so in that example you just had, what I'd probably do is latency as seen at the storage array and latency as seen at the VM, so I can troubleshoot the network between them.
Yes, and let's jump further into that, and I'll show you what we've got on there. So here's a virtual machine. Actually, that's 100%. Let's go with this memory one. I can jump down into the virtual machine level, and I'll show you then how we're correlating and building that picture. So I've now jumped into what we see as the VM itself. I've got some high-level data. It's powered state. That's very useful to know if it's actually running.
Well, when somebody calls and says, I can't access this VM, and you see that it's turned off, that's the easy ones. We like those.
Yes, those are good. I've got all the high-level stats and the attributes. I've got my list of performance policies that we're actually monitoring this on. Here's my topology, how it's actually fitting into the environment. So there's my virtual machine. There's the hypervisor it lives on. It has a NAS connection into back-end storage. I can see everything that's going on with that. I then have the metrics about the device. So here I have all the latency. I've got the I/O. I can break these apart by the reads, by the writes. I can compare my reads versus my writes. And then I can add any other metric that we've gathered on that environment. And as you ask, is it related back to that underlying storage? Well, here's my VMDKs that virtual machine is using. There's the data store that those VMDKs are residing on. There's the storage resource that those data stores are sat on. If I wanted to bring that into the picture, there we go. It's now comparing a virtual machine's performance aspects against the underlying storage. Now, doing that outside of a tool like OnCommand Insight that's got those underlying relationships is extremely difficult, because it's now you're trying to work out on a pen and paper, is this connected to this? I'm opening System Manager, I'm opening Virtual Center, I'm trying to align the screens and the different performance aspects. Here I've got it all in the one.
On your infrastructure level, you didn't show any switches between the
That was my.
virtual machine and storage.
I don't, because this one is a NAS connectivity at the moment. If it was fiber channel, I would have all the underlying switches and all the performance of each one of those components. If I actually wanted to jump down and look at a fabric.
I'll give you how collecting all this data, finding all this data is normally quite difficult. I'll also give you a hint from another vendor's product that'll let you look at the VM latency, and will then go out to the array and go out to the network and show you total latency is 3 milliseconds. 1 millisecond of that is array latency. 2 milliseconds of that is network latency. And so you can, you have the data to deconstruct things that way.
Yeah, we do.
So for IP storage systems, can I discover, do you have support for LAN-based switches and routers that are doing IP storage?
So we do what we call our integration stream, in the fact that we can write a script, or we can use our generic SNMP collector that will start pulling those port utilization stats back from those devices, and then feed them in, and I can create a dashboard and viewpoints of what those look like and how I can then model them next to the those storage constructs and the virtual machine constructs.
So it sounds like discovering support of fiber channel-based networks is a lot more complete here natively than IP.
Yeah, there's a lot of
fair?
there's a lot of network tool sets out there.
That that already do
that
do it.
already do. There's a network team that's very ingrained in the network support tools that they have. It's a very flooded market space.
Yeah.
And in general, it's a different troubleshooting flow. If you're looking at where the bottlenecks are in the network environment, you need to have the network taps in there and the monitoring on the Ethernet side to be able to do that.
Yeah,
There's
but
other ways
you
we
need
can,
to give us enough information to tell the network guys it is definitely their fault.
their problem. Yes. So we
And that includes, knowing all the, dealing with the multipathing and stuff
so
that they don't understand at all.
So on the storage, on the fiber channel network, we will see all those aspects. We will see when there's the load balance isn't correct between the different HBA ports. We'll show that network traffic. We'll show all the BB credit errors, CRC errors, signal losses. We'll pull all those in, and we'll be able to identify on the fiber channel side.
Yeah, for iSCSI, kind of need you to do half of that.
Yeah.
And
Yeah.
do all the parts that storage guys understand that network guys don't, like
Don't.
multipathing.
Yeah. And then we also
That information is not necessary for NAS, you don't think?
There is no multipathing in NFS.
No, it's resilient, not redundant. So
Yeah, you have to do
For
LACP.
example, you
That's the
can,
stuff the network
as
guys
I
know.
analyze the LSCP distribution on the switches or something.
So that's when
you get to
the likes of a network, a pure network monitoring tool are kind of key. One of the other great use cases we have on the, if you're a physical NFS environment and a physical server NFS environment, and you're connecting into ONTAP devices, we can actually monitor the traffic in between the switch, the Ethernet switch, and the storage device, and break the packets apart. Look at the packet headers, where they've come from, where they're going to, and then understand who's the biggest contributor to that load. Really looking then for bully workloads in an NFS environment. So that's another use case we have. But here's some of my kind of correlation analysis. I can see that my virtual machine is highly correlated against its hypervisor, 34%. But it's also greedy on this device's load. So the I/O of this particular virtual machine, I don't know if you can really read that from here, but ending 04-PRD is impacting the latency of my device by 63%. So if I bring that into the picture, I can then compare the two. I can see how they're aligned. The I/O of here is affecting the I/O, the latency of my device. So I have all the performance metrics that you'd want to gather from all your devices. I can then create performance policies on each one of those. So I have the ability to create a performance policy name. Let's do a standard test. Whatever object I want to apply that to. Everything from the virtual machine. Let's do ports, because we can broaden the conversation, and we'll do that fiber channel piece. If there's any annotations that are assigned to the ports in that infrastructure, I can do it based on those. So I'll do as a note. Whatever that port is connected to, host to switch to tape, let's do it to the storage. I can alert after OnCommand Insight has first seen the performance issue start to arise, or anything up to 2 hours. And then I can do a warning or a critical, and then I can send it to an email address, or it will go via the usual systems, to the syslog, to the violations dashboard, or out as an SMP trap. And then here's all my different fiber channel metrics that you guys will probably be very familiar with. Link resets, traffic metrics, encoding errors, CRC errors. So wherever they're occurring in the environment and you want to learn about it, we'll start alerting. Now, if you want to do combinations of those, so I've got one particular port, I'm seeing, let's do signal loss and sync resets, sync loss count. I can do multiples of those, and I can go if it's above a value or below a value as well. So sometimes it's the case when you're looking at a virtual machine or a FlexVol or a LUN that you want to know when the I/O is decreased on it, because what actually happens, something's powered off, something's not connecting correctly. We can do alerts above or below values as well. That gives you a reactive way of understanding what's going on in the environment, but it's not always about being reactive. Everyone's end goal is really, let's be preventative, let's be proactive about discovering issues. And that's where that machine learning capability has really come to its own in OnCommand Insight. So I have the ability to create an application. And an application is a collection of virtual machines. And then because we know the virtual machines' connectivity through the infrastructure, I can bring in their entire stack. Everything from the virtual machine, hypervisor, SAN fabric, down to the underlying disks. And I can feed that information into our anomaly detection engine. In this environment, I've got 6, 7 maybe different application stacks that are being monitored. If I look at the support site, this is what it looks like. This is the overall topology. It's a bit of a beast. It's 4 different storage devices in the back end, multiple hypervisors. It's actually got just short of 100, okay, maybe more, 50, 175 different resources in that environment. Each one of those resources is now feeding into the anomaly detection engine and looking for behavioral changes. In the last 24 hours, there hasn't been any. If I go back 7 days, let's see if there's any more there. I have 90 days of performance data within the system.
That was my question. The granularity of your data, you keep 90 days then, full granularity, and then you
90
start
days full
aging?
granularity, yes. And then we'll roll that out to our data warehouse on a daily basis. And then the granularity goes down and hourly, and it then goes down to, we just kind of age that data.
Okay, but the 90 days that's good, because so many times we have the forensics question, what happened 2 days ago?
Yeah.
And that's all been squished down into 5 or 10 minute increments, and the numbers are useless at that stage.
Yes, yeah, it's full, and as you can see, it's full granularity. I've got the 7 days here at the moment. I could go 30 days, but here, when I prepped for this, I noticed there was an anomaly that was quite nice on this one. Here, I've got an anomaly score of 100. I can look across all these resources. So this would have actually sent out an alert. Someone would have investigated this. I've got 2, I think these are flex vols. I'm assuming they're on tap because it's NetApp IT. They are, I can tell by the naming convention. I can pull these into the graph, and then I can start looking at between 3:30 and 4 a.m. on the 22nd. It recognizes that this behavior for these volumes has changed. So I've got my little gray line here. Let's just take that one out. As you can see, it was actually doing very, very little, if not nothing, was that storage volume. And then all of a sudden, at 3:30 a.m. in the morning, bang, behavioral change. And now, ever since then, it's doing something different. Now, maybe that's not actually a bad case, but would you actually know without something alerting you to it? It's not hit a performance threshold. It didn't breach any of those issues. But it is a behavioral change, and it's probably because someone's done a change in the environment, added a flexible into it, maybe for extra capacity to the back-end application. But from the application guy's perspective, if there was an issue, if maybe it was now having horrific latency, we'd have detected it, we'd have alerted against it before they've probably even dreamt there was going to be an issue.
And the anomaly is a lot somewhere. Can you acknowledge them?
Yes. Yeah, so all those performance policies, all those alerts, there's anomaly detections, they get fed into our violations dashboard. And as this one builds, here you can see all the violations that are actually occurring within NetApp IT at the moment. So I've got everything from what's going on my virtual machines, I've got my capacity issues, storage nodes that are getting high utilization. All those are coming in.
The anomaly detection is something you're doing based on a threshold that somebody's setting, or is it something that you're doing based on the activity that you've seen over time?
It's a learned behavior that the machine's actually learning. So we're feeding it into a machine learning, it's Bayesian network, and it's looking at the behavior, and it analyzes and learns over, it builds after about a 2-week period. So as you turn the anomaly detection on, it ingests previous 2 weeks of data, so it's learned the behavior, and then it monitors going forward. So things like if there's a Monday morning batch run, and that's a consistent Monday morning, it will learn that behavior, and then that won't become an anomalous event. If it was a Monday morning, the batch run occurred, and then Tuesday morning, which you never had before, same batch run, same performance, that's now anomalous behavior, then it will start detecting that and start giving it a significance. And if it believes that significance is enough, we can then start triggering alerts.
And so that behavioral characterization is over a course of 2 weeks, or it starts at 2 weeks
It starts at 2 weeks and then learns.
90 days?
And then it keeps learning.
I'm sorry?
It just keeps learning. Learns and learns and learns. So
So it never forgets what it's seen?
it adapts. It adapts its learning. So behaviors change, and behaviors sometimes subtly change, and sometimes they.
I mean, there's quarterly intervals, there's yearly intervals, there's monthly intervals, things of that nature.
Yep. So it's on the 2-week basis, but it's where it really kind of it's its sweet spot. But it learns what that 2-week basis really looks like in its mindset.
It's a Bayesian?
Bayesian.
Yeah.
Yep.
What he said.
Well, yeah.